Okay, factor to find the three real zeros of p of x equals x cubed plus 3x squared minus 4x. Now, this one specifically says there are three real zeros. What I know for a fact, if it's x is to the third power is the highest power, there are three answers. Those answers may be real, they may be imaginary, okay? So the fact that it says three real zeros implies that they're all real, all right? As we continue on in this chapter, we're going to start solving equations, finding zeros. Some will be real, some will be imaginary, and we're going to find out some specific properties about each of those things. It does tell me to factor. That implies that factoring is possible on this one, which means our answers should be nice, rational numbers. The first thing in factoring that we always do, first thing we always look for is a greatest common factor. And since there's no constant, every term contains x, so I can factor an x out of the expression. If I take an x out of each term, I'm left with x squared plus 3x minus 4. Okay, when we do factor, every factor that contains x squared should be considered as a possible factoring candidate again. If I've got x to the first power, I'm done. I can't make x to the first power any simpler than that. But as long as I have x squared, there's a possibility that I can factor it further. I'm looking at this, I'm looking for two numbers that multiply to make negative 4, that add to make positive 3.
X plus 4 and x minus 1.
4 and negative 1 do the trick, right? So p of x, I'm going to continue bringing p of x equals down. X is the factor that already came out. This red thing factors to x plus 4 times x minus 1. Okay. Once you get it completely factored, everything's linear. X to the first power, x to the first power, x to the first power. Then you simply take each factor equal to 0. So factor 1 has x equal to 0. Factor 2 has x plus 4 equal to 0. And factor 3 has x minus 1 equal to 0. If you have just a numerical factor, such as let's say a 3 came out, and you say 3 equals 0, that's false, it doesn't get you anything. If x's are in factors, x's create answers, numbers don't create answers. All right, so x equals 0 is already done. This gets me x equals negative 4. The green one gets me x equals positive 1. In each case, just moving the number across, the equal sign, changing the sign. So my three real zeros of this polynomial function are x equals 0, negative 4, and positive 1. I'll open my calculator real quick just to verify this. If it's a 0, that means if I replace x equals these numbers into that expression, I should get a value of 0, right? Yeah. So if I were to type this function in my calculator, which was x cubed, was it plus 3x, oops, plus 3x minus 4, or x squared minus 4x. Helps to type the function in right. Okay, there's our original function. If I go to my table and enter my numbers of 0, negative 4, and 1, you can see that we get results. They're all 0. Okay, that just verifies that. Also, imagine this, since we just did end behavior. Suppose we're trying to graph this thing. All right, and let's just say that this information might be helpful in graphing also. We get some graph paper up here. This tells me that 0, 0, negative 4, 0, and 1, 0 are all points, right? Yeah. The end behavior, we have an odd power and a positive coefficient, right? Yeah. That means left, down, right, up. Correct? Mm-hmm. So I know for a fact, looking at this, these three zeros, left, down, right, up, I know that the graph's going to do something along these lines. Without even trying too hard. Yeah, third power, so as I go left, it's going to go down, right, it's going to go up. I got my zeros here, there's 3 points on the graph. If we just take a quick look at the graph, I didn't really do that much, negative 5 to 2, let's go to one scale, and I'll go from negative 10 to 10 at a one scale. Okay, graph, and let's just take a look. It's a decent sketch. I would have needed more information to get a better feel for how high that went. But again, goes down, goes up, goes through the zeros. You can get a pretty decent idea of the graph just with those two traits without doing anything else whatsoever. And as we continue on, we're going to find some more things we can do to determine more stuff about the characteristics of the function before we actually graph it that might help us find a high point or a low point kind of thing.